Okay, so question number third question. To determine the acceleration due to gravity, a small metal sphere is dropped from rest and the time it takes to fall through a known distance and open a trapdoor is measured. You are releasing an object from here. At the moment it comes and falls here, you open the trapdoor and this is the trapdoor. Maybe you have put the sensor here and you are finding out what is the time taken. Okay. Then what is it asking? The following data is available. Diameter of this metal sphere is 12 plus or minus 0.1 millimeter. Okay. Diameter is given. Right? It is the diameter. The diameter. This would be the diameter. So 12 plus or minus 0.1 millimeter. Right? And then 654 plus or minus 2 millimeter is the distance between the point of release and the trapdoor. Point of release. See, don't take the point of release here. Take from here. This is your point of release to the trapdoor. Okay, so I'll write it. The point of release to the trapdoor. So this distance is seen to be 654 millimeter and 654 millimeter. Okay. Then the measured time of fall is seen to be 0.363 plus or minus 0.026. I cannot write here. Okay. Determine the distance fallen in meter by the center of mass of the sphere, including an estimate of the absolute uncertainty to answer 2 marks. So he is asking you what is the distance fallen by the center of sphere. Center of this mass of sphere. Center of mass usually will be at the center of the sphere. That's why he has given you sphere here. Be here also. So which means now he is asking you only the distance between this point, between these two lines. So what I should do? See, this is your radius r. This is your radius r, right? So your net distance from here to here would be 654 minus 2 times r, right? This is what it is. Where is the value of r? Value of r can be determined from here. What is the value of d here? D is 12 centimeter. So 2r is equal to 12. So what I will do is I will write 654 minus 12, it is equal to 642 millimeter. This should be your answer. Okay. Now what I will do is I will call this as some L over here. Sorry, I will call this as your L. Call this as your L and this as your X. Okay. So because we want to find out the uncertainties, if you have some variables, it will be good enough. So from here, what I can write? I can write L is equal to X plus 2R. Can I write the R plus X plus R? Right. So X plus 2R. So X plus 2R will be equal to L. Now what has been asked? Determine the distance fallen in meters, center of mass of the sphere, including an estimate of the absolute uncertainty. Now what is that we have found? We have found out the value of X. Found out the value of X. It means X equal to L minus 2R is what we have got. Right down here, we have got the value of X equal to L minus 2R, which should be equal to, how much you get? 654 minus 12, which is 642 millimeter. 642 millimeter is what we have got. Now we want to find out the uncertainty also, absolute uncertainty. What is absolute uncertainty? Delta X is equal to delta of L minus 2R. Should be equal to delta L plus 2 times the delta R. Right? What is delta L? What is delta L? Delta L, where is delta L here? 2 millimeter. 2 millimeter plus 2 times delta R. What is 2 times delta R? It is delta D over here. It should be 2 millimeter plus what is delta D? Diameter of the sphere 0.1 over here. 0.1 here. 2.1 millimeter should be the uncertainty. But we have to write it for this one. So thus the value of X can be written as a 642 plus or minus 2.1 millimeter is the way how you need to mention this. Okay. Next. Let's move on to the next one. So 2 marks here. 1 mark would be for this and 1 mark would be for this one. The way how you calculate, try to get the final answer, you get for 2.1 millimeter. Okay. Next. Using the following equation, acceleration due to gravity equal to 2 into distance traveled by the center of mass. Write out by variable. 2 into x divided by time square. Calculate for this data the acceleration due to gravity, including an estimate of the absolute uncertainty. Find out the absolute uncertainty also. So what I will write is, I'll write g is equal to 2x by t square. Write this. Substitute all the values. First one, 2 into, what's the value of x? Let me go back and write down the exact value. X value is 642. into 2 into 642 into 10 to the power of minus 3 divided by t squared. What's the value of t? T value was given to be 0.363. Don't take this now. Only take this value 0. The whole square 0. The whole square. Okay, let me take a calculator. Let's find out what is this value. 642 divided by 0.63 one time divided by 0.63 second time I get 9744 multiplied by 10 power minus 3 will be 9.74 meter per second square. You have got the value of G close to 9.3. That's okay, but I want the uncertainty also. So what do I do with uncertainty? I should do delta G by G is equal to delta X by X plus 2 times delta T by T. See, this 2 should not be counted, okay, because it's a constant, so it's not considering this. So therefore, delta X by X, what's the value of delta X by X? Let me go back. Did we find delta X? Delta X we got 2.1. Okay, 2.1 divided by X value 6. Right here, should be 2.1 divided by 6.2 plus 2 times. What's the value of delta T by T? It's already given here. Where is 2? Delta T 0.002 divided by 0.36. Right after also 2 into 0.002 divided by 0.363. I do all this 2.1 here. Remember this. So when I do all this, I get the answer as 2.1 divided by 642 will give you 0.003. 0.003 plus what about this here? 0.002 divided by 0.363 will be 0.005 multiplied by 2 will be 0.011. Now let me add both of them. Take out this. What? Get 3 plus 0.011, 0.014. The value of G would be equal to 0.014 multiplied by delta. It would be equal to so much multiplied by delta G by, because delta G by G, delta G by G is equal to so much. I get delta G is equal to G into 0. That's what I have to write. It should be 9.74 multiplied by 0.014. Should now be equal to this 9.74. Give me 0.136. Yes, nearly 0.14. So this, the value of G, I can now write it as 9.74 plus or minus 0.14 meter per second. Okay. So with this we come to an end to this video, and let us solve the rest of the problem. Okay. Thank you.